Okay, this is Dr. Jim Brenner. We're going to be recording an electrochemical concentration monitoring experiment. This is probably the last lab of the semester. And what we are going to do is measure a potentiostat curve, current versus voltage for ascorbic acid, which is more popularly known as vitamin C. This is for the highest concentration of 100 millimoles per liter, probably too high a concentration for this. We'll see that relatively soon. Okay, I'd like to share screen for a little while, and we're going to go to the instructions here. I'm going to redo the instructions. There is a PowerPoint with audio at Potentiostat experiment.powerpoint. In there, it's going to tell you a few things. You ought to start with what's listed on there under checking Python. Make sure that Python is installed on your computer by going to the menu, then down to Python. Make sure it says Python 2.7, and what you'll want is the idle Python GUI. But even before you get to that, you may need to do what is written in the instructions at the bottom of the assignment here. And I'm going to skip to the bottom of the assignment where it starts to say go to Canvas files, concentration / radiostat. You want to get this should be get pip.py file, and I need to retype that one. You need to get that file and put it in the downloads directory. Just to make sure that things are going to work, I'm going to ask that you go to the Windows key plus R. So I'm going to type in the Windows key and R. And when you do that, you'll go to the Run option. And I want you to type in CMD for command. And once you've done that, I want you to type in Python --version, and it should say Python 2.7.16. If it says that, then you're ready to go to step 2. It says in the instructions, if everything is installed already, you can skip to step 4. Presume that it's not. And then you're going to have to do what's called downloading pip. Right now, that's in the CHE BME 4568, CHE BME 5568 directory. I am going to have to put that into the Canvas directory for, I go to Files, under Concentration and Radiostat, I need to put the get pip.py into this directory. It's not there yet. I have put it into the downloads directory of my computer. So if we go to downloads, make sure that get-pip is in the downloads directory. Then when you get to that point, it's going to prompt you. I guess I need to go back to here. You need to type in the c://user/jbrenner/downloads/get-pip.py. I'm just going to copy and paste the Python with all of that and go back to the command menu, and it's going to tell you that Python 2.7 has reached the end of its life already. It hadn't as of the time when I did this. it should still run just fine. Then in step 3 in Canvas, it says you've got to download some libraries. So you're going to need to go to pip install IO rodeo-potentiostat. And it'll take a little bit of time to run that. Then you'll have to type in pip install pandas. And then pip install matplotlib so that it can plot you a MATLAB library. And in this case, because I had already installed that, it says requirements already satisfied. Once you've done all that, then you skip down to part 4 where it says running the potentiostat. And what you want to do, it says on here that you should use rodeo plus-py 27.py. That is going to get changed by the time that you see this. What you want is a different file, and that different file is going to be named multi-channel rodeo 9-30-2019, and you're going to have to put a .py in the end. And so if I go back to the instructions, what I need to do is type Python C:/user/jbrenner/downloads. But instead of what's listed there, I'm going to have to copy and paste the correct file, which is a multi-channel file. Copy that .py. And the reason you need that is that the one that was listed on there is for a single channel potentiostat. We're going to use one that's for a multi-channel potentiostat. And I am going to stop sharing. Ultimately, I'm going to have to hit return for that, but I want to make sure that Nelob records a few things. First of all, you need to have the red wire connected to the left side on here. If you get really close, you probably won't be able to see that there are 3 pins on there. You won't be able to zoom that far in. The 3 pins say CTR for counter, REF for ref, and then WK and then a number for the working electrode. If you look at these are Pine Instruments. They're Pine Instruments, Pine Research disposable electrodes, although you don't need to dispose of it. The middle one is the working electrode. That's where you'd put your sensor if you were making a custom sensor. And then there's an electrode just above my finger, and then one that goes around the outside that are the reference and the counter electrodes respectively. In order to get this to work, you'll either need a second sensor on both sides, or you will need a piece of cardboard. Otherwise, it will fall out of this little connector right here that connects to the ribbon cable. And then the ribbon cable connects through a little plastic piece here onto what I'm pointing right there. And underneath the cable, there's room for attaching up to 7 electrodes at once for measuring up to 7 concentrations at once. I'm only going to do one for this example. Ultimately, I want you to go around the room, and you're going to record current versus voltage for all of the concentrations that are listed on here. Whoops, you're not seeing that. All of the concentrations that are listed here, 0, 1, 2, 5, 10, 20, 50, and 100 millimoles per liter. And you'll notice that there is a little bit of hysteresis going up versus going back in the potentiostat curves for current versus voltage. And you can use this to calibrate what it is, what the concentration of whatever it is, in this case in solution, is. And we're measuring ascorbic acid concentration. That's i.e. vitamin C concentration using our potentiostat. And I'm going to turn this off. And so on here, could have several of these running at once. I'm only going to run one. On the left side of the potentiostat, there is a fairly odd cable over here that we need to connect up via a mini USB to USB connection. And then there are several of these radiostat multi-channel potentiostats that will be around the room, and you will have to move yourselves to the various concentrations of ascorbic acid, and eventually you're going to reproduce the plot that I just showed you. So how does this work? If I go to the command line again, we type in multi-channel rodeo 9-30-2019.py after the Python. Are they seeing that?
No, they're not seeing it.
They're not seeing that. And so if you go to the bottom and you see Python, C:, etc., multi-channel rodeo 9-30-2019.py, and you hit return, it should start executing, and you'll see this screen pop up, and the minimum voltage should be minus 0.5. Oops, not P.5, but minus 0.5 up to 1 volt. And the current range will be 1,000 microamps for this one. For the lower concentrations, you may want a lower current range. The slope in volts per second will tell you how long you're going to take on this, how quickly you're acquiring data. A good time or a good rate is 0.05 volts per second. So it will take you not that long. We'll acquire 10 samples per second. We'll do 1 cycle, and I'm going to call this 100.text. Actually, make it 100-1.text, since I've already saved one as 100.text. You'll have to select the channel that you're going to use. I'm using channel 1. But if you've got multiple channels, it'd be 1, 2, whatever. And then at the bottom, where it says port/dev/ttyacm pound, that would be if you're using a Mac or using a PC. And so you've got to know what COM port you're on. And for this, if you go to the device manager, my guess is the device manager is only going to come up if you are an administrator, or at least you'd only be able to change it if you were the administrator. And if you go down to ports, our device is USB serial device, in this case COM6. So I'd have to type in COM6 for this to work. When you plug your USB connector in, you may get a different COM port, but make sure it's not the same as the two that are there by default, in this case, COM1 and COM3. And so if I go back to here, I need to type in COM6 and then go to run. And what you will see in the Python panel is it's changing the percentage 1, 2, 3, etc. And when it gets up to the end, it will be done running the entire potentiostat sweep of current versus voltage, and it should plot the results in a MATLAB plot, and it should save the results as 100-1.txt. And so if I go to downloads while this is actually running, there should be a file I'm not seeing. It didn't. I don't think it saved it the last time because I don't think it finished running. It needs to completely save in order to for you to open it up later. It's going to get saved as tab delimited text. Okay, this is what we ran. You can see here that it went a little bit off scale, 1,000 microamps. In that case, we probably would need to change our concentration to make it a little bit more dilute in order to run this. And this is what the data actually looks like. You'd like that to actually plateau out without reaching the maximum of 1,000 microamps. So I've got too concentrated a solution here. Now, it looks like it is still trying to run this, and because I've got this running the MATLAB plot, I think maybe I want to turn the MATLAB plot off because it's giving me a warning that is keeping me from actually finalizing the save on this and therefore finishing this. So I think what we want to do is to get rid of the MATLAB part from this. Okay, yeah, it's giving me a warning, and that's why it's not quitting. And once it's done, it should go back to the C prompt, and it's not. So advice, this is the first time I actually ran the MATLAB library. Don't run the MATLAB library when you're doing it, and it should work just fine. Okay, and I believe that will be it for this particular lab.